Hello everyone, welcome to Mega's tutorial. In today's video, we are going to solve the Hstr 2012 PM method question paper. Please subscribe to my channel. Number 1. A conducting circular loop of radius r carries a current I. It is placed in a uniform magnetic field B such that B is perpendicular to the plane of the loop. Then the magnetic force acting on the loop is given by. So, most of the questions in this question paper are theoretically based. We have to solve them theoretically. Since this magnetic field is perpendicular to the plane of the paper, if we consider two diametrically opposite elements, and since the directions of the current are opposite, forces will always cancel each other due to the value given by dF bar. This is equal to dL bar, that is I into dL bar cross B bar. Okay. Similarly, all forces acting on diametrically opposite elements will cancel out in pair. The net force on loop will always be equal to 0. That is, option number 3 will be the correct one. For this, we are having the diagrammatic representation with the explanation in the current electricity chapter of the second year PUC. You can go through the NCERT textbook for more information. Okay. Next, question number 2. As one journeys along the magnetic equator, the angle of dip will increase, decrease, remain unchanged, increase or decrease depending on the direction of the journey. What happens? So, when one journeys along the magnetic equator, the angle of the dip will always be equal to 0. Always be equal to 0 means it always decreases. The value of these always, it decreases. That is, the magnetic equator is nothing but an imaginary line, roughly, which is considered as parallel to geographic equator, and at the equator, the magnetic equator, the dip or the inclination value, it will be always equal to 0 here, but 0 is not there, so we are considering it as the value decreases. Okay. Next, question number 3. We are having a ship with vertical steel mast navigates the Indian Ocean in the latitude of the magnetic equator. To induce the greatest EMF in the mast, the ship should proceed. So here the horizontal component of Earth's magnetic field B, it is along the north to south direction. It is taken from north to south direction here. So let us consider the velocity of the ship be V, okay, and the length of that conductor B, L, length of the conductor, steel mast. Conductor means it is nothing but the steel mast they are given here. It is taken as L. Then the induced EMF is given by, E is equal to B L V sine theta. Sine theta, where theta is nothing but the angle between velocity and the magnetic field. So for electromotive force to be maximum, sine theta value will always be equal to 1, where the theta value is 90 degree. Hence the velocity and the magnetic field are perpendicular to each other. Then we can say that the ship has to proceed either in the eastward or in the westward direction. Okay. So whoever is new to our channel, please subscribe to our channel and like the video. Number 4, two equal negative charges minus q are fixed at points 0, a and 0, minus a. On the y-axis, a positive charge q is released from the rest at the point 2a, 0 on the x-axis. Then the charge q will, what it does, the charge q, here since the charge force is acting on q, which is opposite from the direction of displacement. So we can say that they execute. The charge q, it will oscillatory motion but not simple harmonic motion. Okay, so fourth one is the correct answer. Question number 5. An air-filled parallel plate capacitor has a capacitance of 1 picofarad. 1 picofarad means 1 into 10 raised to minus 12 farad. The separation of the plates is doubled and the wax is inserted between them, which increases the capacitance to 2 picofarad. Then the dielectric constant of the wax is. So we have to use the formula to solve this. Let us solve it. So capacitance of the parallel plate capacitor in the air and parallel plate capacitor in wax, we are going to divide the two equations and finally we are going to get the K value is equal to 4. Just take the screenshot and you can write it down later. Question number 6. Two positive charges of 12 microfarad and 8 microfarad are placed 10 centimeter apart in air. The work done to bring them closer is. So I think this question is wrong because they have to give the R value here. One R value is given, another R value has to be given, as this is taken from the second year PUC chapter. So it's not given. If you substitute here, actually this problem contains another one numerical value, that is bring them 4 centimeter closer. That is missing, I suppose. So this way, if that is the case, then this will be a grace mark question. If you solve it, you can get the value as 13 joules. Okay. So let us not solve this. ಗೊತ್ತಿಲ್ಲದೆ ಇರೋದ್ರ ಬಗ್ಗೆ ಇಲ್ಲಿ ಹೇಳಲಿಕ್ಕೆ ಇಚ್ಛೆ ಪಡೋದಿಲ್ಲ, ಯಾಕಂದರೆ 2007ರಲ್ಲಿ ಯಾವ ರೀತಿ ಇದನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರು ಅಂತ ನನಗೂ ಕೂಡ ಗೊತ್ತಿಲ್ಲ. ಸೊ ಈ ಕ್ವಶನ್ನ ನಾನು ಕ್ವಿಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ನಿಮಗೆ ಗೊತ್ತಿದ್ರೆ ನೀವು ಕಮೆಂಟ್ ಬಾಕ್ಸಲ್ಲಿ ಹಾಕಿ ಆನ್ಸರ್ನ ನನಗೆ ತಿಳಿಸ್ಬೋದು. 7. When a capacitor is connected to a battery, then a current flows in the circuit for some time and later on it decreases. Okay, it decreases to 0. That is option number 2 will be the correct answer here. The current will always flow in the circuit for some time and then it decreases to 0 when the capacitor is connected to a battery. Okay, so this is option number 2 is the correct answer for question number 7. Next, question number 8. To convert a galvanometer into ammeter, we should connect with it a low resistance in parallel. That is option number 3. Always we are going to consider the parallel connection here for the resistance. That is option number 3 is the correct answer here. Okay, question number 9. A big drive cell A and a small drive cell B have the same EMF, then the internal resistance of A, it is always less than that of B. That is option number 3 will be the right answer here for the 9th one. 10th question we are having. A cell supplies a current of 0.9 ampere through a 2 ohm resistor and a current of 0.3 ampere through a 7 ohm resistor. Then the internal resistance of the cell is, we are asked to calculate the resistance, internal resistance value, that is the value of small r. You are given two current values, I1 and I2, then we are given the two resistances values, R1 and R2. We have to calculate the internal resistance. Okay, let us see how do we solve it. Okay, we are going to calculate the internal resistance value. Just you can take the screenshot of this one and later you can write it down. We are using the formula for E and finally we are getting the value of internal resistance as 0.5 ohm. Value of internal resistance of the cells is 0.5 ampere. That is option number 1 will be the correct answer here. Thank you everyone. Whoever is watching the video, please keep subscribing to our channel, like the video and share it with your friends. Please keep supporting.